In this example, we're being asked to determine if the function is continuous and/or differentiable at the value of the function where the rule changes. So in this case, at x equals 2, then we're asked to sketch the function as well. So what I'm going to test first is the derivative, find out is this differentiable at 2, because if it's differentiable, I know it must be continuous. The derivative of this really just involves taking the derivative of both pieces. So the first piece would be 2x minus 6, and the second piece would be negative 1. Well, at x is greater than or equal to 2, the value of the derivative is negative 2, and so that's for this part. And for the function negative 1, the value of the derivative is negative 1. So, since the derivatives are different at 2, I know that this is not differentiable. So now I will have to go back and figure out, is this continuous? So if I consider my function at x squared minus 6x plus 10, when x has the value of 2, for the first part of the rule, f of 2 is 2. And for the second part of the rule, f of 2 is also 2. So this function is continuous, but not differentiable. If I were to sketch the graph will look something like this. So if I sketch the graph, it's a parabola for this part, and it's a line at this part. There's got to be a sharp corner here, even though it doesn't look that sharp on my particular graph. So it's continuous, but not differentiable. The last example I want to look at would be example 3, which is asking us to find some missing values that will make a function differentiable. So we have a piecewise function again, and the piecewise function is defined by the rule ax squared plus 1 whenever x is greater than or equal to 1, and bx minus 3 whenever x is less than 1. So in order for this thing to be differentiable, it'll also be continuous. So that means that when x equals 1, a times 1 squared plus 1 will equal b times 1 minus 3, or a plus 1 must equal b minus 3, or, solving this a little bit further, a minus b should equal negative 4. So again, all I did was substitute the point where there could be an issue 1, and I have one equation that a minus b must equal negative 4. Because if it's differentiable, then it must also be continuous. If we consider the derivative of both parts, we would have 2ax, and the second part would be b, and when x is 1, these should be equal if it's differentiable, or 2a should equal b. Using these two equations, I can solve for a and b, because b must equal 2a, so a minus 2a should equal negative 4, or negative a should equal negative 4, or a should equal 4, and if a equals 4, then b should equal 8. So those would be the values of a and b that make the function differentiable. Just notice I had to use both the facts of continuity and differentiability to answer this question.